In this problem, I have a wing on the side of an airplane connected at the fuselage. And I have a lift of 45,000 newtons acting right here. I have thrust of 8,000 newtons acting right here. And I have a mass at G of 2,100 megagrams, 2,100 kilograms acting at G, or 2.1 megagrams acting at G. Okay, and again, at A, I'm essentially fixed at the fuselage. So, drawing a free body diagram of that, I have my lift here, my thrust here, just like above. I have 2,601 newtons acting down at G. Again, that is my mass times the gravity. So that's 2,100 times 9.8. And then over at where it's connected, it's fixed. So I have three forces, AY, AZ, and AX, and then MX, MY, and MZ moments potentially over there. Okay, because I'm not allowed to move in any direction or rotate in any direction. So there have to be those reaction moments at A. So, free body diagram's done. Now what I'm going to do is I'm going to sum my forces in the X, Y, and Z direction, set them all to equal to 0, and hopefully find my AX, AY, and AZ values. So, in the X direction, I have, again, AX, and I have 8,000. Which is the thrust acting in the X direction, telling me that my AX is 8,000. And that's actually acting in the negative X direction. You can see I have the negative sign. I have it drawn in the free body diagram going in the negative direction. So as I have it drawn, it's positive 8 kilonewtons in the X direction. In the Y direction, which is this direction, you can see the only force I have is my AY reaction force. There's no other applied force, therefore that AY equals 0. In the Z direction, again, as I have it drawn, I have AZ acting down, I have 45,000 acting up, and I have 20,600 acting down in the Z direction, telling me that AZ in the negative direction going down is 24.4 kilonewtons when I sum these up. And again, this is acting down. I drew it in the negative X direction, so I actually get a positive answer here, meaning my free body diagram is correct here. So, summing the forces in all three directions gives me my reaction forces occurring at point A. Now, in order to find those reaction moments, I have to sum the moments, and I'm going to sum the moments about point A because that's where all my unknown forces are. So I will do that. Okay, so I'm going to do this in all three dimensions and then pull out my X, Y, and Z components. So, some moment about A, I'm going to include my reaction moments, MX, MY, and MZ. Okay, those are my couple reaction moments. I don't want to forget those. And then I'm going to have three cross products. The cross products of the forces at A are all 0. So I have 5J times negative 20,601 newtons. Acting down. So I got 5J cross negative 20,601 K. Going over to the 45,000, that's 15 meters. So it's 15J cross a positive 45,000 newtons. That should actually be a positive. I'm sorry about that. A little bit of a typo. So that should be positive. Then I have the 8,000 thrust, which is going to be 8J negative 2.5 K crossed with the 8,000 newtons in the I direction. Okay, so I've got all of those values right there. Okay, now when I do those cross products, I'm going to have I, J, and K components, which are going to be shown here. Here's my I component, so I'm going to have my MX that I have right here. Okay, and then I'm going to have the 5J cross negative 20,601 K and the 15J crossed with the, again, this should be positive 45,000. So I get 45,000 times 15, negative 20,601 times 5 minus MX. Okay, solving for MX, I get 572 kilonewton meters in the X direction. Moving on to the Y direction, again, I have my Y value, my moment about the J axis, the Y axis, okay, and that's going to be this 2.5 crossed with the 8,000, okay, so negative K cross I gives me a negative J, so MY equals negative 2.5 times 8,000 gives me a reaction moment of 20,000 Newton meters. In the z direction, what I have left is the 8j cross the 8000i. That's going to give me, that's a negative. Don't forget your mz, your moment in the z direction, okay, where that's going to equal 64,000 Newton meters. So again, free body diagram, figure out all your forces, all your moments, then sum up the forces in the x, sum up the forces in the y, the z, set them all equal to 0, and then take your moment, and I find the best way to do is take the moment as a whole and then separate out your x components, y components, and z components, and solve using those three equations for any unknowns that you have.